So before we get into the agentic flow and the application, I just quickly wanted to touch upon the use case that we are going to show you. So in this use case, we are going to create the optimized formulations. So we have some of the ingredients using which and some of the property that need to be targeted. And we are going to find the optimal mixture of these ingredients to get to the desired property. So how are we going to do that? We have a master agent which will catch the user intent in the natural language. This master agent is enabled by knowledge graph. So knowledge graph not only provide the context to the master agent, like which all ingredient are present, what are the permitted values of those agents in the history, etc. But it also enforces the guardrail, the constraints, which are very important for any optimization workflow. And then there is an formulation agent, which is going to do the actual AI related work. So it is going to generate the design of experiment. Then it is going to predict using the historical data, and finally optimize and give you the most recommended formulations. So let's go into the interface and see the demo. Okay, so now let's look at the interface of mcube, and this particular module is the agent builder, agentic framework, or agent orchestrator. So here we create the agents. So before we get into the different options which are available to build the agent, let's look at some of the results first. So this is the chat node for rapid prototyping. I'm going to go to the chat node and I will start asking questions. So what is this formulation demo all about? And this is a primary question to our knowledge graph agent, because here we are not invoking any of the AI agents. Basically, we just want to understand what are the ingredients, what are the properties, and so that we can ask subsequent questions as a new scientist or as a new user. So here the master agent is getting the intent from my question, and then it will invoke the subsequent sub agents to get to that answer. So now it says that formulation demo involves experiment with 3 main ingredients: resin, solvent, and plasticizer. And then there are 3 output properties: dynamic viscosity, clarity, and tensile strength. So now my next question would be to generate, let's say, 15 experiments, new experiments using design of experiment. So I will say that generate 15 using full factorial. This is one of the method for generating the design of experiment. And if you look at the question, I have not asked anything about or not informed anything about the constraints. So what should be my range of solvent? What should be my range of plasticizer? So that's where knowledge graph agent comes into picture and enforces the guardrail, even if a user will not give it. Now, if I give those information and if I want to override the guardrail, that is still possible, but that will still be limited to certain law of thermodynamics, which is or law of chemistry, basically, which is being again enforced by the knowledge graph agent. So here you see that knowledge graph agent is bringing all the guardrails. What should be my lower limit and upper limit for resin, solvent, and plasticizer, and then my master agent is calling the formulation agent to design 15 new experiments, which you can clearly see here using full factorial method. So this helps us to set up the experiment in my lab. Now, if I say that, okay, I want, if I take first of this experiment and I want to predict the clarity, tensile strength, and viscosity. Now, so I will say predict the properties for the experiment with resin 10%. I'm doing the approximation. Solvent 33%, and plasticizer will be the rest basically. So now the model, it will invoke the prediction model, and that prediction model will predict the predict different properties such as viscosity and other properties. Now, as a next step, I am going to ask, what is the can you rank 5 top recommendations if I want to maximize the viscosity? So that is going to be my next question. So by the time we are getting the answer to this question, I will quickly show you, because now AI model is being called. Oh, we have already gotten the answer. So here you see that with this particular combination, we get some predicted value for viscosity, clarity, and tensile strength. And now let's say that generate top 5 formulation to maximize the tensile strength and minimize viscosity. So now all the modules will be called basically. So it will call the knowledge graph for information, then it will call the prediction model and optimization model. First it will call the optimization model, and optimization model will internally call the prediction model. So everything is interrelated. Now by the time it will generate, oh, it has already generated, it's quite fast. So it has generated me top 5 ranked formulations for the maximum tensile strength and minimum viscosity, as you can see here. Now let's look at the internal working of this agent, how the agent has been created. Here you will see that there are multiple agentic framework. You can create the agent using either agent development kit or LangGraph, and you can also add your own A2A agent. So if any one of your external agents are hosted using A2A protocol, you can just add it and import it into our workflow and start using it. So that will become part of your agentic mesh or agentic workflow that you are going to create using our mcube application. Now, if I deep dive into the agentic sub workflow, here you will see that we have a knowledge graph agent and a formulation agent, as I was showing in the PPT. And then there are lots of tools. All these tools are being called using MCP protocol. So here you see I have prediction tool, I have DOE generation tool, and I have optimization tool. And if I go to any one of these agents, here you will see that we have the option to plug into any of the model provider and models. So we can use either self-hosted internal model if we want to host our own model in the GPU for data security, or we can connect to any of the external LLM providers. So that's all for this demo. Over to you, Andy.
Thank you, Ashutosh. It's very obvious that a lot was going on while we were chatting with this system. Maybe you could summarize and explain how this formulation system with its agentic nature is different from a traditional non-agentic formulation tool as they exist in the market.
Right, great question. So when we look at the traditional formulation tools, so all of them are mostly workflow driven or step based. So you do this step, then you go to the next step as a scientist. The fundamental difference between this system, agentic system, is that everything is integrated and end to end. As a user, you don't have to go to 5 different interfaces, and think about how to operate it. Only one trigger is your either your text that you are typing in the window, or it can be voice enabled as well. So as a scientist, you are just interacting with one formless interface, and it is orchestrating internally between multiple agents for different specialized for different works, and then it is giving you the final output in a, again, a semi structured format.
So if I understood this example correctly, the scientist begins with a desired outcome rather than raw data, like in many other advanced analytics projects. So how does 5.4 enable the system to respond to that intent and generate ranked formulation options?
Right. So everything starts with scientists expressing a goal to the interface, right? So for example, I said maximize, let's say, tensile strength and minimize viscosity. It goes to the master agent, which interprets the intent. So that master agents need to be very powerful in terms of reasoning, so that it can take the user input, and it's a freehand text, right? So anyone can come and write anything. So that's where it becomes very important to for the agent to interpret that when I am saying maximize tensile and minimize viscosity, I am talking about optimization objective and not about generating new experiments to be done in the lab. So that's how that is the main role of master agent. And here knowledge graph actually plays a very important role, because knowledge graph is the place, knowledge graph agent, where all these different steps are mentioned. So it acts as a brain to the master agent. If you have seen the workflow, it is connected to the master agent.
Right, right.
So these two is like steps are very important to go further and invoke the formulation and get the work done by the formulation agent.
Okay, so we have seen up to 5 recommended formulations, like you asked for. So what determines how these are ranked? And more importantly, how should a scientist interpret those rankings?
Right. So again, ranking is based on the goal that scientist has entered in the chat. Here, I myself said that I want to maximize something and minimize something. So what happens is that like the system, the optimization module, it simulates lots of different possibility. And out for all those possible experiments, it actually call the prediction model. And prediction model, even without doing the experiment, predicts based on the historical data, predicts what should be the viscosity and or the strength or the clarity for these combination of mixtures, right? And in that case, what happens is, so once this all these value comes in, then it's all about filtering and converging towards a better goal. And when I say optimization model, we generally use optimization models such as Bayesian optimizer, or even more complicated like differential evolution or genetic algorithm, which actually works on the principle of mutation. So it has like child, and then it mutates, and it again creates new offspring, and it just drive the entire curve cost function into minimal, like to minimize it. And once it reaches a asymptote, that's where it gives the output back. So those five uh, basically those five formulation that you have seen have minimum cost function, which has been created internally by optimization function.
Thank you. Thank you. So a very basic change happens here, right? Prediction and optimization are unified within one application rather than run as separate analytical steps. So
Right.
That is the main difference, I think, in experience and in time that you spend to come to the same result. And it might be that the result is even better because there is, in that amount of time, a combination of orchestrated agents can run a lot more simulations than a human being can. So one more time, we are giving, we're leveraging the human for what the human's good at, and we're leveraging the agents for what the agents are sometimes better than us. So thank you so much, Ashutosh.